Okay, good. So HDFS. We'll be looking at what is the HDFS, what are the components are involved on it, and how the data will be stored, and how will we retrieve the data, and what are the main components are involved on it, like name node, data node, secondary name node, right? And who will manage the cluster. All these things we'll be looking at in a further class, now today's discussion. Okay okay so we have seen a big data. That big data we are not able to store, manage and process using traditional approach, right? Now how we can do the same, how we can do same using HDFS, that we'll be looking at now. And before that, I would like to give some introduction about DFS. What is a distributed file system and what is the HDFS? There will be two. One is a distributed file system, another one is Hadoop distributed file system. HDFS means Hadoop distributed file system. What is this? The Hadoop distributed file system is a virtual layer on top of your local file system. If you see in your local file system, which is very local to your OS, it means that your OS will have a more control on your IO operations like read and write operations. So your that means that is local to your operating system. That is the reason we are saying that the local file system, that is the reason we are calling it as a local file system, which is it is local to your OS. It means that your OS will have more control on it. Your OS will define it. What is the why? If I want to read, how much data has to read at a time? If you want to store, how much data I have to store at a time? That IO operations will have a more control on OS. Operating system will have more control on your read and write. When it comes to HDFS, Hadoop distributed file system, we will be having more control on it. Like we will define at a time you read this much of data, at a time you write this much of data, or if you write the data, you don't update it, you just append or replace the data, right? So these information, these controls will be, we will be having, I think whoever configure it, the end user will be having control on it, right? The HDFS is a virtual layer on top of a local file system. Virtual layer on top of local file system. It is like there will be, even though we are talking about HDFS, that in the below there will be local file system only. When we talk about HDFS, that HDFS layer, that is called virtual layer, will be there on top of local file system. Even though we are specifying 64 MB or 128 MB as a block, internally it will collect a small 4 KB blocks as, and it will make it as a one big block, right? Which will run on top of local file system only. Now let's talk about DFS. What is distributed file system and what non-distributed file system? Distributed file system means the data will be distributed into multiple machines. Multiple machines are connected through a network. The HTTP protocol is the communication channel, and the data will be transferred through one machine to other machine, and multiple machines are get connected. That is a distributed file system. We will store the data across the network into multiple systems. Okay, and how it differ from the Hadoop? It is differ from the Hadoop when it comes to the data locality. In a normal file system, in a normal distributed file system, let's assume you have a 4-node cluster. Normal file system. I'm talking about normal distributed file system. Okay, you have connected 4 machines with the high bandwidth and high network bandwidth and nice protocol. You have used HTTP protocol, and the 4 systems are connected, and 4 systems have stored the different kind of data. And there is a client machine. The client machine is connected to the cluster, distributed file system, and the client machine is sent a request for reading some data. What it will do, it will collect the data from these four nodes. It will collect the data from these four who are connected in the distributed machines, right? It will get the data to local. It will get the data to local client machine, and it will process there. What it is happening here? Data is traveling towards the network, and it's coming to the client machine. There it is processing, which is not a data locality, right? When it comes to the HDFS, other way, it is different way. In a Hadoop distributed file system, it will not get the data. Your logic will go and execute on all the machines parallelly. It will execute on all the machines parallelly, and it will give the result very quickly compared to normal distributed file system, right? When it comes to the DFS, we have to handle the socket programming and all. We have to say how the data has to transfer one data node to another data node. The socket programming, there is a socket programming in Java. We have to take care of that. The programmer has to do that. But when it comes to the HDFS, it is by default the Hadoop framework has that functionality. We no need to handle any socket programming. Clear, guys? And when it comes to the DFS, we have to handle a node failure things. Let's assume there is one data node is failure in a DFS, and we have to replace with another one. I mean, it's not like replace with another. The handling, how to, if it is failed, what to do? We have to handle it. But when it comes to the HDFS, we no need to worry about much, because the data will be always replicated twice or thrice. Depends on the configuration, or more also possible. If any data node is failure, let it go, not a problem. Your master, your name node, I'll explain those things, those terms. He will take care automatically. He will balance the automatically. That we will not be losing the data in that. But when it comes to the normal distributed file system, we will be losing our data. Clear, guys? Any doubts? I think I'm not able to see your screen because it is. Let me minimize it. Okay. I hope everyone understand this. This is the difference between DFS and HDFS. Okay. And what is the problem if we don't have the DFS or HDFS? The problem is, let's assume you are handling with 1 GB data. Will not take the huge amount of data. Will take only 1 GB data. And not without distributed. I mean, it means that not distributed. Normal way. You have a single machine where you will have a 1 GB data in that, where you have IO, I mean, cores or 4 core or 8 core. There parallelly 4 IO operations are happening. And to process the data, you have executed some query, you have given some query, it is taking to execute that 4 minutes or 10 minutes. Let's assume that it is 10 minutes. Then what I have done, I have implemented a distributed manner. I have implemented a distributed manner. In that, I have stored this 1 GB data into the multiple machines. And each machine is capable of handling 4 IO operations at a time. I mean 4 core. Ideally it is a 4 core. I have issued a query. Without distribution, it is taken 10 minutes. Where I have a 10 machines, 10 without distribution is taken 10 minutes. Where I have a distributed manner, where I have connected 10 machines, 10 nodes I can say. And when I issue the query, 10 IO operations. It means that 10 machines are executing parallelly. It will give me the result in a 1 minute. When it comes to the without a distributed file system, it will take 10 minutes time. Even though to make the 10 machine cluster, I'm not using high-end computers. That's what we have seen. We are using commodity hardware, right? So where we are achieving, I mean, performance, I can say we are getting the results within a few minutes or few seconds. That is more important than you are investing on the hardware. Okay, let's see an example here. The same example without distribution. Can you please give an example for local file system? Okay, local file system. What we have to understand here, that file system is local to your OS operating system. Like your operating system is already has been defined. Your already has been defined. When you write or read, it has to be read at a time 4 KB. We will not have any control on it. Whatever your operating system is telling to the file, the IO operations, they will do that much only. But when it comes to the hdfs, we are defining the blocks. We are defining that this much data has to be processed at a time. We have the control on it. The hdfs is a virtual layer on top of the local file system. Clear? Yeah. So before distribution system, we have all data into different machines. When it comes to the distributed manner, all the data will be there in the network. I mean, in the cluster. Okay. I mean, this is a simple example what I have explained you now, and it's not that much important. We'll see. Now HDFS. Then how to comes with the distributed manner? Right? Like that's called distributing the data into the multiple machines, which is called HDFS. HDFS is Hadoop Distributed File System. Okay, and it has been defined for storing a huge amount of data in a commodity hardware and manage it and to process it. Okay, to process we have a different component is called MapReduce. We'll see that, and we're talking about HDFS now. The HDFS is for storing a huge amount of data in the multiple machines with a high throughput. High throughput means the results are coming very fast, and with the fault tolerance means if any data is lost, we can recover the data easily. Okay, we will see what are the things involved on it. We'll see the architecture of the HDFS, how they have designed it, how the data will store, how the data will get, how we are breaking the blocks and all. We'll see that. And this HDFS contains mainly three nodes. Okay, the first node is name node. We'll call him as a master, and other one is data nodes. We call them as a slave nodes. Here the node is a technical term for a computer. It's just like a node. It's telling that it's a one technical term for the computer. And it's a name node means he's a master, and data nodes are the slaves. And there will be secondary name node. We'll talk about him. It's not actually a backup. We'll talk about him secondary name node in the next slides. And name node is responsible for managing the whole cluster, managing the data nodes. Like in our IT industries, our team leader or our team manager is responsible for managing the team members. I just want to try to correlate with a real-time scenario. Let's assume most of the cases I'm just correlating, right? It should not be always same. Most of the clients will interact with only your team leads. They called as a sprint lead. Sprint means they will sprint means these 15 days you have to finish this work. That is called sprint. For 15 days they will define the sprint. Some people will take 2 weeks, or some people will take 3 days, 3 weeks. Okay, in the 3 weeks your team has to finish this work. That is called sprint. Okay, that's called sprint. The client will talk always with the sprint leaders. They will not talk to the team members until unless they have specific questions, or until unless they have specific requirement. And your sprint leads are name nodes, and your team members are data nodes. Your sprint lead, I'll say him, I'll call him as a lead. Your lead, he is responsible for assigning the work to you. He is responsible for to get it done the work, and he is responsible to managing about like your leaves, or he is responsible to plan according to your availability, what is the work you are doing, how much workload you have, and what are the in coming days, what are the leaves you are going to take. All these things will be managed by your lead. The same way, when it comes to the hdfs, your name node will be managing this. What is the cluster size, I mean not plus, yeah, cluster size. What is the data stored in that, I mean in the data node. What is currently, what is processing, what is its capacity, and what is its capacity, I mean how many mappers and how many reducers can launch. All those things will be knowing by your name node. When it comes to the your real time scenario, your lead knows that what is the technology or you, I mean what is your capacity, what is your technology capable of, and how many tasks you can handle, how many bugs you can fix. All this information will be managed by your lead. The same way here, your name node will be managing all these data nodes. He will be knowing that what is this data node, what are the data has been stored in him, and what is the capacity of how many mappers he can launch, how many mappers he can reduce, he can do, what is the current state of him. All the details will be managed by your name node. Clear, guys? Any doubt? Please let me know if you have any doubt. Now, let's see the architecture of HDFS. This is the high level architecture of your HDFS. Okay, this is high level architecture of our HDFS. One second, guys. I think she has some problem. Let me. Okay, guys. This is high level architecture of our HDFS. If you please have a look about the I mean this architecture. I mean most of the guys knows it, and for the new guys who are not aware of it, please have a look. Okay, we have a name node here, and we have a data node, and these are the data nodes. Okay, and now we will talk about our architecture a little bit of. First, we will understand what is architecture, and this is actually a backup node, or you can call it a checkpoint node, or you can call it as a secondary name node. Okay, we'll talk about this guy in a few more slides, after few more slides. Okay, I think I'm audible to everyone, right? Except Anusha. I think Anusha was complaining something. Could you please acknowledge me, guys? Yes, audible. Okay, fine. Okay, and let's talk about the architecture. Okay, you don't worry about these guys. The third layer, it is like just representing that your data nodes are capable enough to store some data. Okay, so nothing data node connect no, it not connect to anything else. It's just representing, ideally it's just representing that your name node is capable enough to store the data, okay, and process the data. That is the that is the idea behind this four database symbols. Okay, now let's talk. We have, as I said, name node. Node is a technical term, as I said, it's for the computer. And your data nodes. Okay, the data nodes are responsible for storing the data and processing that data. And how it will be managed, it will be managed by your name node. How the name node knows which data node is live or which data node is dead, and which data node has no doing current task. I mean, how it will know? The data nodes keep sending a heartbeat. Ideally, we'll say it is a heartbeat. It's like some kind of signal to your name node. For each 3 seconds, it will send an RPC call, RPC remote procedure call to a name node, saying that in the call it will send the status. status that I am alive, I am running this task, I am storing this data. Like that, the information will be sent to a name node. Each data node will send this information. If any data node, if didn't send a heartbeat to 10 seconds, it will treat that as it is a dead node. And what name node will do, name node will mark, it is maintain the, it is like it is maintained on Excel sheet, right? Like our lead, he will maintain on Excel sheet. The Ravi, he is leave from this days, Ravi is doing this work. Like that, how our lead will maintain the Excel sheet, even here your name node will maintaining some status, some, I'll show you that as well. It is maintaining some status tables. In the tables, it will mention the dead node IP address. It will mention this IP address in the that table. Okay, it's like which is not able to reachable. That node IP address will be mentioned in the one. Let's assume that it's a table. In the table, it will enter the whichever the data node is not responding. That data node IP address will be mentioned there, and it will be treated that node is dead until unless the comeback that node is recover, or someone has made some changes, someone, our administrator or someone is boost up, or someone is repaired, I can say. And when it's repaired, when this starts sending the heartbeat, then it will remove the entry from that table and it will make it as a live node. Okay, now communication between name node to data node is a RPC call, remote procedure call. And communication between data node to data node is HTTP call, where we will send the data, where we will transfer the data. When in an RPC call, it will just transfer the status, it will not transfer any data, I mean just some information. But the data node to data node, the communication is happen through a HTTP protocol, where we will transfer some data on requirement basis. Okay, your data nodes are sole responsible for storing the data and processing the data. Okay, and your name node is responsible for maintaining the complete cluster status and health. No, name node should be a good name node should be a good configured computer. I can say it's not the commodity hardware. Name node should be have a good configuration, because name node is a single point of failure. We'll talk about that. What is a single point of failure? Because our lead should be our lead. That's what. Though all those things we will cover Meghna in a coming slides. Okay, that is the reason our lead should be very strong. Our lead should be strong enough in a multiple technologies. All right. So our lead should be very strong about the project. He should have a good knowledge about our project, right? Our lead should be strong. That is the reason here when it comes to the name node should be strong hardware, like a good hardware, not like a commodity hardware. So in the same manner, when it comes to HDFS, this also should be a good hardware, not the commodity hardware. Because name node fails, if your lead is disappeared for some time, how client will knows the status of about us? Because we don't have any communication with the client, we don't have any direct communication. Every time we are going through, one second guys, someone is pinging me. Just make it. Okay, let's assume our lead is disappeared for some time. How client will come to know about our status, what we are doing? First of all, he don't know who are all. The client will not know who are all there in the team. I mean, it's not a real scenario in the real world, real IT. I'm just correlating with it, right? Client will not at all come to know who are us. Client will not at all come to know to whom to talk, right? That is the reason the name node, the lead should be very strong, and lead should be, it should be very strong hardware here. When it comes to the name node, it should be very strong hardware here. Okay, the failovers and all will be looking at that. Clear about the architecture, guys? Please remember, the communication between data node to name node is a RPC call. The communication between data node to data node is a HTTP protocol. And the communication between name node to secondary name node is a HTTP protocol. This will be one of the interview question. If he will really want to understand whether you know the architecture or not, he will be asking that question. Any doubts in the architecture? About this failure and all, we will be looking at failure. If the what happened if the name node failure, what happened if the backup node is failure, or what happened if name node is failure. All these things we will be looking at. Name node to data node RPC.
Ravi,
Yeah, Bharat, tell me.
so data nodes will keep sending this RPC signal for every 3 seconds to name node,
Correct.
correct? Yeah, between a name node and secondary name node, will secondary name node keep pinging name node, or will name node keep sending signals up for like
Very
if regarding that communication? Can you confirm that?
okay. Very good. Here, the secondary name node to the name node to the secondary name node, we will configure for what time it has to be contact. Ideally, it is a 1 hour. Okay. Also, the
Okay.
name node to secondary name node also, there is a one more configuration called the transactions with the cluster. If it is reaches 1 million, the data node will communicate with the name node. Sorry. Your name node will communicate with the data node. So your secondary name node.
Secondary name node. Yeah, got it.
There
Okay.
are there are two configurations, which is a periodically it will keep yeah, hourly basis. Ideally, it is hourly basis will communicate your name node
Yeah.
to a secondary name node. Another communication is that when your transactions means your transaction with your cluster reaches 1 million records, 1 million times, that data will be that time also it will be communicated to your secondary name node.
Okay. Okay. Yeah, got
Okay.
it. Thank you,
Name
Ravi.
name
Yeah.
node name node to secondary name node is not RPC. Ideally, as I know, it is a HTTP. Vamsi. Okay. Name node to data node RPC, data node to HTTP. Correct. Data node data HTTP. Correct. Yes. What's the info present in data node? So what's the info present in data node? Okay. The actual data, what are the data we are storing into the cluster, like in hdfs, like your images, like your videos, like your data, your text files, your structured data, unstructured, whatever the data you are storing, whatever the data, it is not there is no specific data only will go, whatever any kind of data you can store in the cluster. In a data nodes it will store. Data nodes contains the actual data. The name node will not contain any data. Name node will contain only the statuses of your data nodes. Like, your team lead will not do any work. He will just manage the cluster. He will not store, he will not take any bugs, I can say. But in real it is not in a case in the real time, but I'm just trying to correlate. Please try to understand this. In the real time, your team lead will not get assigned any tickets. What he will do, for him it is enough work. Let's say he has a 40 members of team. When he has a 40 members of team, he has to manage to everyone. He has to get the status from everywhere. What he is doing, what task has to assign, what is his skill. So if the UI guy, if I assign the database task, he may not be able to do. All this information will be managed by your lead, right? So in that situation, your lead will not take any story points. It means that your lead will not take any bugs to fix. He will just manage. The same when it comes to the HDFS, your name node will not store any data apart from the status, health check, apart from managing the cluster. Only our team members will do a real work, but team members will do a no will take the bugs and they will fix it. Like that, here your data nodes will take the data and they will store the data and they will process the data. But if you want to talk to your data, or if you want to get the data, you have to talk to your name node. Without communicating your name node, you cannot do anything in the cluster. In the same way, the client or any ex person, without talking to lead, he cannot talk to us, because the third party, I can say, the other person will not know about us. In the same way, here the client or client machine will not know about us, I mean about data nodes. When he talk to the name node, then only he'll come to know the data nodes. The same way, here also, the third person, the client, in the real time, the client will come to know about us when he talk to lead. there won't be any direct communication with us until unless in special cases. The same way here also, if your lead gives a permission, then only client will talk to us. The same way in HDFS architecture, your name node gives a permission to the lead, then only he will talk to the data nodes. The client will talk to the data nodes. We will see that. Any doubt, guys? Okay. What are the parameters in heartbeat signal that will be sent to the name node? Good question, Vamsi. I'll show you the picture for that. Most of the cases, like the status of the data node and whether it is, I mean, status of it, and it will be what data has been. See, whenever the new data comes, like this data block belong to which file, that information also will be sending to the name node. Your name node will maintain maintain the status, like block to node and block to file. That mapping will be there in your name node. We will see all these details in the further classes. Okay, and one question to your guys. Okay, anyway, this is not the right time to ask this question. It's an interview question. We'll see in a further slides, then I'll ask you that. Okay, is there any chance to heartbeat signal fail to reach name node? Yes, there are some chances, like your network is failed or your data node is not able to send because of low memory or because of something happened to your data node. Your data node is not sending the uh, it's not sending the heartbeat to your name node. That time it will treat it as a dead node or failed node. Clear, Ramsey? Yeah. Okay. Any other questions, guys, about the architecture? I think it's very much important to understand the architecture. If you know very well about the architecture, you can answer any type of questions from here. Okay. Commands and all we will see. HDFS commands and all we will see. I'll show you the commands. What are the commands are available? All the commands we will see. But you should understand what is the architecture in a high level, in a deep as well. Is it clear, guys? Can we move to other slide? Okay. Okay. Good. Let's see other slide. What are the features of your HDFS? It can store the huge amount of data, where it's called as a data sets, large data sets. And other one is warm. What is warm? Write once, read many. It means that you store the data only once. You cannot update the data here. You can append the data to existing data by using merge. I'll talk about that merge, the command. Okay. Write once, read many. Like your Java program. Write once, execute any place, right? The same way here in our HDFS, you store the data once and you can read any number of times. And it's a batch processing. Batch processing means the huge amount of data can be processed. Like, it is not like you can store the data, later point of time you can generate the analytics. Or streaming access. Streaming means the data keep coming. You can do that and you can keep do the analytics on it. It is not like a data is coming now, immediately you'll give the reports. That is called real time. That is called streaming. Okay. And we'll talk about the splits and blocks now. We'll see how the data will store in a HDFS in the form of block. The data will be stored in HDFS in the form of blocks. We should understand that what is a block. We'll see in another slide. And what is a physical split? The physical split is nothing but a block. Okay. One more thing, guys, when it comes to block, then the local file system, the block size is 4 KB. When it comes to the HDFS, the block size is 64 KB or 128 KB or more than that, or you can configure. Why it is? We'll talk about that in another slide. This is an entry question. This is the sure entry question. If you want to understand your knowledge level in the HDFS, he will ask a question like why block size is 64 or any 64, 128 or 512 or 1 GB in HDFS. Why? What is the reason behind they have made it as a bigger block? That is a very good. That will be a sure question. You should understand this. I'll explain you why it is. Okay, and high fault tolerance. High fault tolerance. High fault tolerance means if any data node is failure, we don't need to worry about it because our data is already replicated. Already we have a data. We can take the data. What is the high throughput? High throughput means you store the data, you send a query, you will get the results in a fraction of seconds or in some minutes. Like the high throughput, the results are coming very fast, and we have, it's completely depends on your cluster size. Completely depends on how many mappers and how many reducers running, how many slots are free, how many core your hardware is belongs to how many cores. I mean, in the hardware, how many cores are there, how many IO operations are there. So all this comes into the picture when it comes to the performance. And data replication, we are doing the replication of the data for to avoid this fault tolerance. I mean, it's a fault to avoid the data loss. We are storing the data in a multiple places, and that's called block replacement policy. We will see that as well. What is a block replacement policy? There is a policy to store the blocks. We'll see that. Okay, it's a commodity hardware. You guys know that it is a commodity hardware. Clear about this features of your HDFS? It will store the large amount of data. It will store, it is the write once and read many, and it is do the batch processing as well as the streaming process, and it will store the data in the form of blocks, and it is a high fault tolerance because we have data replication, and it is a high throughput because we have a big cluster where we'll get the results in a few seconds or in few minutes, depends on the requirement, depends on the data. And we are using here a commodity hardware, not the high-end computers. Clear, guys? Okay, fine. Now we'll see one by one actually. What is a large data set? The HDFS has been designed to store a large amount of data. Man, as we see that the HDFS is Hadoop is a solution to big data problem, right? It is not solution to the small data problem, right? The Hadoop is he's invented or he's invented for solving the big data problem. It means that where we have a big data, we are not able to process using the traditional approach. That problem we will solve using Hadoop. How will then Hadoop is meant for what? Large files. Hadoop is meant for big data. Hadoop is not meant for the small files. Okay, why it is? I will explain you in the another slide. Remember this question: why Hadoop is not meant for small files? Small files, because the small when in the cluster when you start storing the files, the data will store in the form of blocks. If it is a small files, if it is a small files than our block size, it's a burden to your name node because your name node has to maintain each and every where the block is stored, which this block is belongs to which file, this block is stored in which data node. All this information has to be stored by your name node. If it is a more small files are there, it is a more burden to your name node. Okay, we'll see that as in detail. And what is this WOM? WOM stands for, as I said, write once, read many. So in a HDFS, once you store the data, you cannot update the same data. But through Hive 1.4 onwards, we have a row level updates or row level inserts. We will see them when it comes to the Hive. Okay, I mean upgradations. It depends on the versions. There are new features are introducing. So by using here Hive, we can update the data. That we will see how we are doing updations. Okay, by using the scoop, I can say you can do incremental appending the data. That's appending, that's not updating, but still there also we have update. We'll see that as well. Okay, HDFS is append only file system. Before it was like that. Now there are some tools where we can do update as well. Why we have done this append only? Why is not update? Because as I said here, the data to avoid the data coherence. Okay, along any dots guys here? The WOM is ideally saying that write once and read many. Okay, so I'm moving to next slide. Can we explain about the data coherence?
Ravi,
Okay,
yeah, that is what I was about to ask. What is data coherence? Is it repetition of data or what?
Okay. See what will happen if you don't have the if you didn't if you start updating if you start updating the data here, it's a write once, read many. When you update it, the data will be duplicated, the same data will be duplicated. So you may talk about the data replication is there, block replication is there, right? Block replication is the different block it is, and different machines it is. When it comes the same block in the same machine, if you start updating it, start updating it, what will happen? Some other tool may be accessing the same data. Let's assume that I have put one text file, and that text file is accessing by your pig, and the same the pig team, and the same file is accessing by your hive team, and the same file is accessing by on the MapReduce team. And when we append some data, when we add some data, or when we update it, because the old data has been deleted and the new data comes, so we will end up with the unknown results, right? Is it clear, guys? We will
Yes.
so to avoid that, we have a data to avoid that, we don't have the updates in this.
Okay, Ravi. Got it.
Okay. Or if anyone wants to explain anything, it's always welcome. If anyone wants to add any point to that, either Anusha or most of few guys are knows about, already gone through the training, so I just want to understand. I'll tell you what is append only, Vamsi. I'll tell you what is this. Okay, anyone wants to add any point here about the data coherency? See here, the data coherency means the data has been spread across the network, right? The spread across the cluster, and people will be using the same data. When change the data, when you updated and you deleted some data by updating it, some old wala you updated with a new thing. Okay, what will happen? This will Those guys who are already accessing using some other tools or some other applications, they will end up with the unknown results. So that is the reason, to avoid that, to avoid that, the hdfs is meant for only append only append only system file system. Okay, and Chandu has pinged something here. And computer science cache coherency is the consistency of shared resource in the data that is end up with the storing multiple local machine caches. Okay, it's a totally some technical terms. Is there a way avoid to stimulus data access in order to avoid the inconsistent results? Okay, is there any way to avoid data accessing in order to avoid the inconsistent results? Yes, that is what we have. HDF has come up with the only append only the system, right? It is not like the existing data we are modifying. We are adding some extra data to that. Um, could you please reframe your question, Vamsi? If I'm not able to understand this, is there any way to avoid simultaneous data access? But to avoid inconsistent. Yeah, that I think to avoid the inconsistent results, that is the reason the HDF has come up with the only append only file system, not the update. Okay, let me try to understand what is the simultaneous. I'm not able to understand the meaning of this. Can you, Vamsi? I'm sorry. Simultaneous. Okay. Yes, simultaneous access is possible in HDFS. It is possible. It means that one data comes into the HDFS, the multiple tools can handle the same data. MapReduce can take the same data, or your Hive can take the same data, your Pick can take the same data. Some other tools also can access the same data, but it cannot update. It can append the data, right? When it comes to the HDFS, it cannot update. it just can access the data. You may ask, what happened in Hive? In a Hive, it is totally different. In a Hive, it will take the data into its own warehouse system. Suppose, let's assume that you have a data in some location called user, and you have created a Hive table on top of it. Sorry guys, I'm going some other I'm talking about some other tool here. For the new guys who not understand the Hive, please don't worry about it. We will see in detail. I'm explaining to Vamsi and other guys who are uh, uh, already aware of bit advanced about these tools. And Vamsi and Bharat, other guys, when it comes to the Hive, let's assume we have stored some data in hdfs and we have created a Hive table on top of it. By referring this data, so are you do you get a chance to look at what is happening? What it will happen, the data will completely move from hdfs to Hive warehouse system. That data will not be, it will not available on the data will not available on your hdfs. I mean, ideally it is hdfs only, but the location will be warehouse system. The data will be in warehouse system. It will not be in a hdfs. Because of that, your Hive can do any number of updations, deletions. No, it can be possible in that. That is the reason most of the cases we will create external tables in a real time. Very rare scenarios we will create managed tables. Most of the scenarios in a real time we will create external tables in Hive. Okay, sorry guys, we are diverting to completely on other new other topic. Let's other guys to understand from the basics. Okay, when it comes to the Hive, I'll give full details about it, how it will work in the real time. I'll show you the example as well. I'll show you some real time projects as well. No need to worry about it. Clear guys? Shall we move to the next slide? Okay.
Yes, Ravi.
Okay. And what is the batch processing and what is the streaming processing? Very simple. I just want to explain in a very simple way. The batch processing is that you're sending the data. You are sending the data. On top of the data, you are not expecting the results immediately. You want to do that operations at later point of time. You may gathering the last 10 days data and you are doing analysis on it. So it is not immediate. It is not immediate results. The data come into the cluster. It's not immediate result. This is batch processing. And when it comes to the streaming processing, the data keep coming to the HDFS. As soon as the data come to the HDFS, the job will be keep running and it will be keep resulting the outputs. These are real time reports. That is batch processing and streaming processing. That is the only difference. For the streaming, we have a different kind of tools like a Flume, Kafka. There are different type of tools. In batch processing, you can keep the data using hdfs put command. Most of the cases, the data will be there in external machines. We will be getting the data through our programming language or through our business logic, ideally say. Okay. So if anyone wants to, they can go ahead and read out the slide. What is a batch processing and what is a streaming processing? It's ideally it is showing the data locality here. Batch processing is nothing but once the data comes to the HDFS, we may take the data for last 10 days or we may store last 15 days data into HDFS, then we will process it. That is batch processing. Now, that is streaming processing means the data directly coming into your HDFS, and as soon as the data comes, your job will be start executing and start generating the reports. Okay. Okay. Anyone wants to read out this guys go no the new guys Mani Kumar or Chendu, so you guys can go ahead and read it and you can understand. Once you guys said okay, then I'll move to next slide. Okay, I think money is okay. Okay. Okay, we are moving to next slide. And guys, this is very much important. One more important question from interview point of time. I mean interview point. The question is like in your project, what is the mode? I mean, what is the processing? What is the way of processing? Whether it's a batch processing or streaming processing? You must be very much clear about when you are explaining about your project. if you explain the streaming data, there will be more questions on it, like what tool you are using, how frequency the data is coming, how frequently your job is running. These questions will be there. If you say batch processing, you can say last 10 days, last 15 days, I will take the data and I'll process it, I'll generate the reports. So very simple. When you say streaming data, you should be very strong about Flume, or whether you are using a Flume, or whether you are using a Kafka, or whether you are using some other tool, and you have to be strong about the tool, and you should be strong about how the data is coming and what frequency and how many, what rate. I mean, I can say how many seconds or how many minutes the keep data is coming, how long you to generate the reports, how long it is taking. Okay, for Bharat, Meghna, and other guys, this is very much very be clear when you're telling about the batch processing or streaming processing, about when you're explaining about your project to a interviewer. If you say your project,
Yeah,
I personally suggest always go with the batch processing. I think in Hadoop
yeah,
it's
sure,
always
Ravi.
streaming data, right? Or batch processing also. Batch processing also possible. It is not always streaming. It is not always streaming. It is a depends on the project. Let's assume I have I mean, as I said, I have done one project for a PwC company, right? There, for PwC, they're using the streaming data. They'll keep getting the data from one ICSA application server, where they will be getting this ICSA Lombard, I think insurance, you guys know, right? They'll be keep getting the logs, or they'll keep getting the information about the customers, policies, and all those things by using Kafka. That data will be keep pushing to the hdfs. As soon as the data comes to the as soon as the data comes to the hdfs, they'll generate the reports. That is streaming. Batch processing, I can say my project, my current project is batch processing. We are taking last 10 days data, last 15 days data, last 1 year data, or we are storing into hdfs, and we are processing it. Yeah. But online analysis is streaming process, correct? Online analysis is a streaming process, correct? That is called OTP or OLTP, I think. It is a streaming process. Okay, clear, guys? So shall we move to next slide? I think you guys understood what is it. And now this is the place to understand how the data will be stored in HDFS. The data will store in HDFS in the form of blocks. Okay, what is a block? Here, block is a chunk of data which will store in a machine or data node. Why block? Because anyway, in the normal file system also, our data will be stored in a piece of 4 KB piece of data. When it comes to HDFS, our data will be broken into pieces. It's like a divide and conquer, the rule, right? So the here, whatever the data you're putting into HDFS, what it will do, your HDFS client or your Hadoop client or your job client will break the data into pieces, and it will store the data across the cluster. How it will store, we will see in detail now. Let's assume I have 1 GB of file. I want to store that 1 GB file into HDFS, and my block size is, I have configured my block size is 64 MB. I will show you the configurations, guys, because this is an architecture explanations. I'm not storing, or I'm not explaining all the configurations. I'll be showing the configurations as well. Okay, and I want to store this 1 GB file into HDFS, and my block size is 64 MB. Okay, now when I use the Hadoop fs -put and I give this file, I mean from destination to source, when what it will happen? When you issue the command, the job client, ideally it's also one job, right? The read and write operations I'll show you guys. Don't go in detail about this. You just try to understand high level. Now this data will be broken into pieces. The 1 GB data is broken into pieces like small blocks. 64 MB, 64 MB, 64 MB. 1 GB means 1024 MB means 1020, 1024 MB, right? This is broken into, I think ideally 18 blocks will come. 16 to 18 blocks will come. Now, these 18 blocks will store in the cluster. How it will store? What it will do, it will, the flow I will explain you. Okay, the first, it will make sure that the same block will store in it will make sure that the same block will not store in the same data node. Like let's assume that block 1, block 2, block 3. There are 3 blocks, and your cluster is 90 node cluster, 100 node cluster. It will make sure that block 1, block 2, block 3 will go on different machines. I mean, ideally it is like block 1 will have a 3 replications, right? B1 will be having 3 replications, and block 2 will be having 3 replications. Block 3 will be having 3 replications. It will make sure that the same block will not go into the same data node. It means that block 1 will go to one data node. It can be possible. Block 1, block 2, block 3 we can store in the same data node. The replications of this block, like block 1, 1, block 1, 2, block 1, 3, these replication data will store in different machines. Let me put, let me let me take any of the text file here. Let me take a text. I'm taking this. Okay, I have a block 1. Okay, these replications are, let's assume that these replications are b11, b12, b13. Okay, I have block 2. Guys, are you guys able to see my screen? b21, b22, b23. I have block 3. Let's assume that I have a block 3. Its replications are b31, b32, b33. Okay, now I have a data nodes d1, d2, I can say dn. Okay, not d, it's a dn, data node 1, data node 2, data node 3, data node 4. Let's assume that. Now, when I say store this data into my hdfs cluster, the data will go, it will make sure that b1 will go to dn1. I mean, it's not always, it's not like a b1 should go dn1 only. It's not like that. That there is a policy. I'll explain that. Because of I'm giving an example, I'm just showing here. And b2 will go to data node 2, and b3 will go to data node 3, and b11 will go to, it will not go to the same machine, should not go to the same dn1. It will go to, it may go to dn2, right? And b21 may go to dn1, b31 may go to dn4. It's a depends on the cluster availability. It will send there. Depends on the block replacement policy. Depends on the block replacement policy. It will go and store there. It is not always will go this manner only. I'm just giving an example. I'm making sure that the same block will not, the same replicated block will not go into the same machine. That's what I'm trying to show here. B113 it will go data node 3. Now B12 will go to already B1. Okay, B1 will B1 not B1, yeah, B12 will go to B12 will go to data node 3. Okay, there is no duplication there. Data node 3. B22 will go to, I can say, data node 4, because I didn't store anything in data node 4 as of now. B32 will go to data node 1. dn1. Okay, because actually this is one block and these are the replications. There won't be 4. I mean, let's assume that there won't be 3 replications. Clear, guys? Clear how the data will store in the cluster? It will make sure that in cluster the data will go, the same data will not go to the same data node. Okay, I'll be pasting it here. If anyone wants it, they can have a look later point of time. Okay, and I'll be showing that slide. I'll be slowing. Yes, no, this is not the one. Take, let me take, yeah. If you see this, okay, the block one, the block one went here, and the block two went to data node two, block three went here, right? Three blocks are placed. Now the replicated blocks has to be go, and block two one will go here, block two one, not the block one two. Block two will go here, block two one. I think block two one ideally. It is block three one will go here, and block one two will go here, and block two two will go here, block three two will go here, block three one will go here, right? It means that ideally what it is storing here, it is not storing the same data into the same block into the one data node. Clear, guys? Clear? I think I'm concentrating on money. Is it clear to you? Because money is new to this thing. So you understood, right? The cluster and how the blocks are going in a cluster. If let's assume this is one computer, this is one computer, this is one computer. When I have a same blocks, like say b1 b11 b12, all the same data, this is kind of the same data, that the same data will not go into the same machine. B1 will go here, b11 will go here, b112 will go here. It means the same piece of data will go different machines. Okay, if you are clear, it means that everyone can understand easily, because you are new person, you are a fresher on this. So okay, and why the block size is 64 MB, or why it is 128? What if the data nodes are less? Okay, so if the data nodes are less, depends on our data node, our cluster size only, we will define the replication factor, Meghna. So when we talk about the replication factor, it's totally depends on the number of or size of the cluster. And also there is one more configuration called min replication factor. It has to be satisfied that at least that minimum the store has to be there. Let's assume you have only two data nodes, but your replication factor is 3. Ideally, it is not the case. It is a under replica, but it will store the data in two data nodes. The third replication will not go. Third replication will not go because your min replication factor is 1. Okay, let me reframe your question. My cluster is only 2 node. Okay, 2 data nodes are there, but I have given the replication factor 3. I have only one block. Just assume only one block. Now I want to store this one block into 3 machines. Ideally, because there's 3 replication, and my minimum replication factor, there is a one more minimum replication factor is 1 by default, right? When I put this data into 2 node cluster, it will go on store because it is satisfied the minimum replication factor, but the cluster will always intimate you that it is under replica. Under replica in the sense it has to replicate 3 times, but it has only replicated twice, but it is missing the third replication. So your cluster always intimate that it is under replication. When you go and check the health of the, when you check the health of your cluster, it will report you that there are these many nodes are under replica. Okay, under replication, this many percentage of under replica will be there. So minimum there has to be 2 data nodes always. It's, yeah, it should see what how much data you're handling. Suppose you're handling huge amount of data, 2 data nodes are not enough. It's more than that, right? So it's totally depends on how much data you're handling, how much data you can store in one cluster. Say how much, what is the performance you're expecting. We want the faster results, we should go with a bigger cluster. I mean parallelism, right? So ideally it's a parallelly processing the data, right? So we should have a minimum bigger cluster. It is not like always you have 2 data nodes or only one data node. It is not like that. You can have only one data node, one name node. There is no problem in that. But the data will be stored only once. There won't be replication for that. And the processing time will take more to process the same data. Clear, Meghna? I hope it's clear. And why The block size is 64 MB or more than that. Why not less than that? Anyone can? I think I already explained you. Anyone wants to try to give it, guess or try to explain someone? Anyone? Okay. So in local file system, the block size is 4 KB. The block size, why block size is 4 KB? At any time, any point of time, if I want to read data from the local file system, it will start reading 4 block at a time. 4 block at a time. It means that you process 4 KB of, sorry, 4 KB of, not 4 block, sorry, I wrongly said. 4 KB of block will be processed at a time in the local file system. But when it comes to the Hadoop, what I'm trying to say here, for me, you process at a time this much of data, not the 4 KB data. Okay. And here, when you are reading, it's called seek time. We should understand seek and data transfer. There are two things we need to understand. Okay. One is the seek time, another one is the data transfer rate. The seek time is, let's assume you have a, if you have a small block, the seek will be no, reading the small block and it will be transferring the data, right? When the block size increase at a time, one IO operation will get completely 1 block at a time, right? The seek, to reduce the seek time, I mean to reduce the seek time and increase the data transfer, we will go with a bigger block. If it is a small block, what will happen, it will start reading the small data every time and it will transfer the same data. But when it comes to the big data, it will start reading the one big block at a time and the data will be transferred at a time. What is the minimum and maximum block size that can we can give? There is no min and max no conditions here. Min and max, I can say minimum block size and maximum block size. You can give maximum is whatever you wish, but you should be keep in mind that if you give a bigger block, it will take time to process. It will take more time to process that block, because one block will be processed by one mapper. Ideally, it is a split. I'll talk about that later point of time. Ideally, one block will be processed by one mapper. If you give a block size as 512 MB, or if you give 1 GB or 256 or 128, that much data will be processed by one mapper. And minimum, if you give very small block, that will be burden to your name node. If you give very small block size, that will be more burden to your name node. You should be keep in mind this, and you should accordingly have to calculate it. Ideally, 64 MB is a good idea, or if anyone wants the lesser cluster, if they have their only 5 node cluster or 10 node cluster, they want the faster results, then you guys can go with and 65 or 32 MB as the block size. But when you go 32 MB, okay, I'll explain that question, Chandu. I'm just explaining to Vamsi. Okay. Min maximum. I think you, Vamsi, you're clear with minimum block and maximum block. Okay. Now, can we give something other than multiples of 64 MB? Yes, we can give that. We can give that. Okay. And yeah, Chandu, why we have a 64 MB or bigger block? The only reason is to read that much of data at a time, to process that much data at a time. If you start processing 4 KB, your block size is, let's assume that 4 KB, and your uh, if you store one huge, the Hadoop is meant for the big data, right? If you start storing the 4 KB blocks, that block mapping has to be burdened to your name node. That is one point. So in a 1 GB, how many blocks? One 1 GB, how many 4 KBs will be there? There will be more. 1 lakh plus it will be there, right? So it has to go in our name node. One lakh one lakh record has to be entry, and your name node will be burden. That is one reason. Other reason is decrease the seek time and data transfer. 1 second, guys. Understand? 1 second. I'm just taking water. Okay, why 64 MB? Why not less? If you go for a lesser block like a local file system, 4 KB or 4 KB, the burden will be on your name node because it has to maintain so many records in that. That is one reason. Other reason is if you make it a small block, the mapper will be processing the small block, and if you start processing the small block, I think it has to launch more number of mappers. So the Hadoop is meant for the bigger files, not for the smaller files. So 64 MB is a small, no, 64 MB means it's not a small block, it's a bigger block. So at a time, the 64 MB data will be processed. Clear, Chandu? Ideally, uh, to increase data transfer. Okay. And reduce the seek times. See, every four blocks, the seek will go and read every time. Every time it will go and seek the 4 KB, 4 KB. But here you go and seek the 64 MB block, and data transfer, you transfer the more data. So what we are doing, we are reducing the number of seeks and we are increasing the data transfer rate. So you are getting the good, I mean, the time of processing is getting no reduced, right? If you go with the local file system, every 4 KB the seek has to go. The IO object has to go and read the data. The seeking the record every 4 KB. But here we are trying to seek 64 MB block at a time or 32 MB block at a time and transfer that much data at a time. Not the small amount of data. Send 32 MB or 64 MB data at a time. That will reduce the number. That will reduce the processing time. That will reduce the data transfer, right? Time of the data transfer. That is the reason we have a bigger block. Guys, if you guys are not clear about this answer, please ping me. I will answer this question in a better way, because it is an important question from interview. If you fail to answer this question, they'll start, that will be negative impression on us. They'll start thinking that we don't know. Is this question is clear? Why 64 MB? Why not less? Okay, very good. And block is a physical split, or block is a physical memory of where the data is stored. Okay. Okay. And yeah, if you see this slide, if you just read this slide, you'll understand more, I think. So used to balance the load each map and reduce throughput. That's what throughput. If you process 64 MB, you will get the results more. If you process the 4 KB, you have to wait for all 4 KBs has to finish. In the 64 MB, how many 4 KBs are there? 4 KB, not the MB. For 1 MB, 1024 KBs. Like that, 64 MB. Okay. I hope I'm clear on this. Okay. Let's move to what is the fault tolerance. Okay, guys, before starting this, it's close to 8 now, 7:53. People may wants to leave for offices, so may I stop here or you want me to continue? Depends on your responses. I'll continue or stop the class. It depends on your responses. Till 8 tomorrow. Okay, only 2 votes. What about others? Tomorrow, fine. Till 8. Okay, tomorrow. Okay. Okay, guys, I think most of the guys are asking for tomorrow, or few guys are asking for 8. 8 means another 5 minutes only. If you have any questions, start ask. I'll answer. I'll start this new concept. I mean, a new topic tomorrow. Let's stop. Okay. I'll continue the fault tolerance tomorrow onwards. If you guys have any questions, if you guys anyone wants to stay back and ask me questions, no, for the interview process, or if anyone scheduled for this weekend, these guys can ask me questions. I'll start answering them. Clear, guys? So yeah, other can leave for the day. Can we get recorded video? Sure, I'll share this recorded video. I'll upload to the drive and people can get it. It's okay. Thank you. I think I can stop the recording because if you start recording empty things also, it may take huge memory or huge. What is this? Okay, I'm stopping it.